Question 25. Which statement here, which statement is correct? And they're saying adding sodium oxide to water gives a lower pH than adding silicon oxide to water. When you add sodium oxide to water, you're actually going to get sodium hydroxide. Okay, you get sodium hydroxide. The pH here is so high, it can be like 14. Now, when you add silicon, than adding silicon oxide to water, silicon 4 oxide is actually not soluble in water. That is why when we have silicon 4 chloride, then plus water, there is a hydrolysis reaction that happens. We get silicon 4 oxide, which is a solid, then plus the HCl. You see that? Yes, so this one doesn't react with water. It comes out as the white precipitate. So this one is wrong. Then B, the oxidation state of sodium in its chloride of sodium, it's a +1, is higher than the oxidation state of silicon in its chloride. Now silicon here, in its chloride here, the oxidation state is a +4. Now how can 1 be bigger than +4? Even that one is wrong. Then see, the atomic radius of sodium is larger than that of silicon. When you look at sodium, it is 11. So this is 1s2, 2s2, 2p6, then 3s1. Okay, but when you look at silicon, silicon is 14. 1s2, 2s2, 2p6, 3s, 2, 3p1. Is it 3p1 or 3p2? I think 3p2. Now you are adding many electrons to the same shell. They all have the same shell. We are in the third principal quantum number, the 3, or the third shell. Now, since you are adding a proton to the nucleus, you have already added 3 more protons to the nucleus. That means the nuclear charge is bigger. Okay, so since the nuclear charge is bigger, then the nuclear attraction for the outermost electrons is stronger in silicon compared to sodium. So that means the atomic radius is going to reduce because it is compressed. They are attracting the electrons much more in silicon compared to sodium. So the atomic radius in silicon has to be smaller than that of sodium. Okay, and here they say the atomic radius of sodium is larger. Indeed, it is going to be larger. This one is going to be smaller. So the answer has to be D here. Okay, so that one has to be the answer. But when you check this one here, D, the melting point of the chloride of sodium is lower. This one has a giant ionic structure. And then silicon 4 chloride is actually simple molecular. Okay, simple molecular. That is why it can be hydrolyzed by water. It can be hydrolyzed to give us these products here. So this is simple molecular. So giant ionic, that means you are going to have a higher melting point compared to this one here. So this one is wrong.